All right, so I wanted to try to do a video where I walk you through step by step, and I'm going to try to uncover the pieces as I go to help you understand. So if you watched my Ed puzzle, you learned that we are now trying to convert from one unit to another. So the first unit conversion we learned is called Avogadro's number, and it goes from atoms or particles, molecules, anything that's like a tangible piece, like an atom or an ion, like an actual piece. It can go from that to moles, and moles is a counting unit that we use. And so you can write it either way. You can write it where you have particles on top and moles on bottom because these are equal to each other. Or you can reverse it where you have moles on top and particles on bottom. So we can use this conversion factor either way, just depending on what our problem is asking us for. If it's asking us for particles, then we'll use this one where particles is on top. If it's asking us for moles, then we'll use this one where moles is on top. Okay, so the problem that I have here says how many moles are in 5.02 times 10 to the 24th atoms. Okay, so I made it very simple at this point where I'm not even including what type of atoms. We're not having to deal with going from compound to type of atom or anything. We'll do that next. This is literally just saying how many moles are in this many atoms. So no matter how your problem is set up, no matter what it's asking you for, you are always going to write your given and write your goal and figure out what you need to get there. So our given is right here, the number that we were given. It's how many atoms we have. Our goal is the question, how many moles? So that is our goal. So we're trying to go from atoms to moles. So how are we going to get there? Well, I just gave you this conversion. So we are going to consider either one of these for the moment, okay? We are considering the Avogadro's number where I go from mole to particles or particles to mole, okay? Either one, we're going to use one of these. So the way that we work factor labeling problems, yes, these are called factor labeling. You are going to set up what's in pink, this pink arrow right here. This pink, you have a fraction line, and then you have this vertical line. The vertical line is meaning multiply the pieces, and the division line is meaning divide. So the way you work these is you want to put this setup in, put what you know, what you're given, right here in this first blank. There should be nothing on bottom for the moment. So what you're given right here. Okay, and then you're going to use a conversion factor until what is left on top is what you are looking for. Okay, until what's here is what you're looking for. I'm looking for moles. So I'm going to use the conversion factor that leaves me moles on top. So this is how you work it. This is your fraction bar right here. This is your, right here. This is your multiplication bar. So you're going to multiply the entire top, and you're also going to multiply the entire bottom. Then you're going to take that whole top and divide it by the entire bottom. Okay? So the units will cancel, but all the numbers stay. So you're going to take whatever is in, sorry, I'm doing this backwards. Whatever is here, multiply it by whatever is here. And then you'll take whatever's on the bottom and multiply it by whatever's on the bottom. Then you'll take this answer that you got from on top and divide it by the entire answer on bottom. Okay? So let's go back to our specific problem. Again, we were given this many atoms and we're asked for moles. So I'm going to take what I'm given and put it on top of this first spot on my factor labeling bar. Okay, and since atoms is on top, I'm going to choose, this is the conversion factor I want, either the mole on top or the mole on bottom. Remember, particles can be atoms, molecules, or ions. So, since I have atoms on top right here, I want to choose the conversion factor that has atoms on bottom. So this is what I'm going to put in place right here, where the atoms goes on bottom and the moles go on top, okay? And so the atoms, the word atoms will cancel out. I can do that for you. The word atom cancels with the word atom, and then we're left with moles, which is the unit that I want right here, okay? And so then all I'm left with is 5.02 times 10 to the 23rd times 1. all of this divided by 6.02 times 10 to the 23rd. So I'm going to put that in my calculator and show it to you. So in my calculator, I'm going to open parentheses and say 5.02 times 10 raised to the 24th, close parentheses. That's my first step. Okay, then divide that by, or hold on, let me do something for you. .02 times 10 raised to the 24th. If you want to keep this consistent, you can remember that this is the top, and so I need to multiply it by 1 right here, just so that you don't forget to do that. If it's not a 1, that number would go, if it wasn't a 1, then that number would go right there. Make sure that all this is in parentheses. Okay, click enter. Then divide that by the entire bottom. 6.02, entire bottom is 6.02 times 10 to the 23rd. In parentheses. So I did the first one and then I clicked enter, so I got this answer right here. And then I took that answer and I'm dividing it by the bottom, and then I'm going to click enter, and this is the answer to the problem, 8.33. So my answer, let me turn it. So my answer is 8.33 moles are in 5.02 times 10 to the 24th atoms. This many atoms gives me this many moles. Okay? Remember, mole is just a counting unit. So this is just like a counting unit of atoms or molecules or ions. Okay, so here's another problem. We're going to be going the opposite direction, but we're still going to work it exactly the same way. So this one says how many molecules. Molecules, again, is just like a piece. So this is like an atom or a compound or an ion. Molecules work the same way. How many molecules of CH4 are in 1.52 moles of CH4? So it's important to notice that now I did include the actual element. Last time I did not. I didn't include what we're dealing with. I just, oops, wrong one. I did not. I just said how many moles are in this. I didn't tell you what we were dealing with. But we're always going to be working them like this, where we have like molecules of something and we're asked for moles of something. Now in this scenario, it's asking for the same something, okay? So we're just going to write our given, which is 1.52 moles of CH4. You always have to include what the substance is, and we're going to write what our goal is. Our goal, again, is how many is what we're looking for, so that is our goal. So again, we're asking ourselves, what conversion factor do we need to go from given to goal? Well, this is a one-step scenario because I have moles of CH4 to molecules of CH4, and I know that I can use Avogadro's number to go from moles to molecules and back and forth. So just to remind you, this is the conversion factor I'm going to use. Either this one or this one, but they're the same thing. It's Avogadro's number on top in moles or Avogadro's number on bottom in 1 mole. Okay, either way, it's exactly the same thing. We can use this card whichever way we need to use it, depending on how our factor labeling works out. So you're going to write your given on the top of the factor labeling bar. And since you have moles of CH4 on bottom, you're automatically going to put moles of CH4 since you have moles of CH4 on top, you're automatically going to put moles of CH4 on bottom. And remember, this is going to be a conversion factor. So I am going to use the one that has moles on bottom, which is this one. So it's going to look just like this, 1 mole, and then Avogadro's number on top, 6.02 times 10 to the 23rd molecules. It's looking just like our conversion factor. So then your moles of CH4 is going to cancel with moles of CH4, and you're going to be left with molecules of CH4, which is what I'm looking for. So now we just put it all in our calculator. Let me find my calculator. And again, you multiply the top. We're going to multiply the top numbers, divide it by the entire bottom, which is just 1. So in my calculator, I'm going to show you. I'm going to put 1.52 times, open parentheses, 6.02 times 10 raised to the 23rd close. This is what I have in my calculator, this bottom line. 1.52 times 6.02 times 10 to the 23rd, because that's what this says. Remember, you multiply at the vertical line and you divide by the bottom. But the bottom is just 1, so I don't have to worry about doing that. So I'm going to click enter, and this is my answer, this bottom number. 9.15. And then do y'all see the e to the 23rd right here? Okay, my answer is not 9.15. My answer is 9.15 times 10 to the 23rd. That's what that means. So let me write that in. So that's my answer. So this is how to go from moles to molecules, or moles to any kind of particle. Molecules, atoms, ions of the same substance. So the next one we have is a little different. This one says how many atoms of hydrogen are in 2 moles of CH4. So if you notice, your given is CH4 and you're asked for hydrogen. So that means that we're going to have an extra step to go from CH4 to hydrogen before we can get to atoms. But don't worry, I'm going to outline it all down here. So you still work it the same way. You write down what you're given, which is the numbers right here. And you write down what you're looking for, which is your goal. So I'm trying to get to 2 moles of CH4 to how many atoms of hydrogen. So you notice there's a disconnect right there. CH4 and hydrogen are not the same thing. So we have to first get to hydrogen moles before we can get to hydrogen atoms. So the first thing we need to do is to go from moles of CH4 to moles of hydrogen. Now we're just going to use the ratio for this that's in CH4. So like 1 mole of CH4 has 4 moles right there of H. You see how there's 4? So it's a 1-to-4 ratio. I'll show you how to work that down here. And then once we're in moles of H, then we can go to atoms of H. Okay? So we have kind of like a detour before we can get back to what we're looking for. So we're going to go from moles of CH4 to moles of hydrogen, then up to atoms of hydrogen. So this last step is what we've been doing, where we use either one of these 2 options here. Okay, we just use the one with the particles on the top or the moles on top, depending on what we need. So again, you're going to write your given down, which is 2 moles of CH4. And since moles of CH4 is here, I want to put moles of CH4 on bottom. Now, like I said, I'm trying to get to moles of hydrogen. So I'm going to put 1 mole of CH4 and use the ratio to get to mole of hydrogen. So that makes the moles of CH4 cancel. And now I'm in moles of hydrogen. So I'm going to put moles of hydrogen on bottom and say, okay, now I need to get to atoms of hydrogen. So I'm going to use this one that has moles on bottom and atoms or particles on top. So now I'm using Avogadro's number. So now moles of hydrogen cancels with moles of hydrogen, and all that's left is atoms of hydrogen. So in my calculator, I'm going to multiply everything on top and divide it by everything on bottom. So I'm going to say 2 times 4 times 6.02 times 10 to the 23rd divided by 1 times 1. So there you can see right there I have 2 times 4 times 6.02 times 10 to the 23rd, this in parentheses. Then I'll click enter and I will get my answer right here. 4.61, is that a 6? No, 4.81 times 10 to the 24th. So that 81 is going to round up to 82, and I'm going to get 4.82 times 10 to the 24th atoms of hydrogen in 2 moles of CH4.